In this video, I'll show you how to solve the ALEKS problem called Understanding How Kinetic Energy Scales with Mass and Speed. In this problem, we have 4 different objects. They have different masses and different velocities, and we're being asked to rank them in order of increasing kinetic energy. The kinetic energy of an object is calculated by the equation 1/2 mv squared, where m represents the object's mass and v represents the object's velocity. So basically, with this equation, what we know is that as the mass of an object increases, its kinetic energy also increases. As the velocity of an object increases, its kinetic energy increases as well. So when we take a look at our objects, you're going to notice that there are some commonalities or some patterns in these objects' masses and velocities. So for example, I can see that 3 of my objects have the exact same mass. You might have 2 objects with the same mass. It's a little bit different for each version of the problem, but you are going to see some trends in the masses. And then you're also going to see a little bit of trend in the velocity as well. So I have not quite as much of a trend with my velocities, but I have 2 objects with the same velocity and then 2 different velocities. So because there's a lot of commonality in our data, that means that even though this is technically a mathematical problem, we don't need to use our calculators or actually do any number crunching to rank these objects in order of kinetic energy. What I'm going to suggest that you do is take a look at these objects and find objects that have either the same mass or the same velocity. So by that, that means that you could start by comparing these 2 objects because they have the same velocity, or you could start by comparing these 3 objects because they have the same mass. And honestly, it's not going to make a difference what you choose to start with. I am going to choose to start by comparing my 3 objects that all have the same mass. So because all of these objects have the same mass, when I'm calculating their kinetic energy, the value of mass is going to be the same every single time, and their relative kinetic energy is going to be based only on their velocity. As the velocity increases, kinetic energy increases. So for these 3 objects, the one that has the highest velocity is going to be the one that has the highest kinetic energy. And in this particular problem, ALEKS is ranking the highest kinetic energy as number 4. And as the velocity of these objects decrease, their kinetic energy decreases as well. And we're just comparing them. We're not actually calculating their kinetic energy. We don't have to do that. So I've got these 3 objects ranked relative to each other. They all have the same mass but different velocities. And so I used their different velocities to rank them. Now I need to bring in this last object, figure out where it fits in this pattern. And for this last object, I want to find another object that has something in common, either the same mass or the same velocity. So I'm going to choose this object right here. Both of these objects have the same velocity. Again, looking back at the kinetic energy equation, both objects have the same velocity, so we don't really want to think about that variable. As mass goes up, kinetic energy goes up. The object with the heavier mass has the higher kinetic energy. As mass goes down, kinetic energy goes down. The object with the lighter mass has the lower kinetic energy. So that means that this object's kinetic energy is lower than the 65 kilogram object, and that's going to be our overall lowest. Now, again, when you're working on this problem, you're not going to see the exact same situation as I had. By that, I mean you're not always going to see 3 of identical masses with 1 different mass. You might see 3 identical velocities and a whole bunch of different masses. Or you might see 2 identical masses and then 2 other identical masses with different velocities. But either way, you want to start by finding 2 or more objects that have either the same mass or the same velocity, compare them to each other, and then just start adding the other objects into the mix. Now, if all else fails, you can actually crunch the numbers on these. You can actually plug mass and velocity into this equation and calculate kinetic energy and use that to rank and solve the problem.